The following presentation is about the work that was recently published in Remote Sensing Journal with all the authors listed here. In the work, we studied the vertical distribution of Arctic methane from 2009 to 2018 using ground-based remote sensing. A Fourier transform spectrometer, Bruker IFS 125HR, has been operational at Arctic Space Center in Sodankylä, North Finland since spring 2009. It is part of the Total Carbon Column Observing Network, the TCON, and the retrieval method presented here uses the standard TCON spectra measured with maximum optical path difference of 45 centimeters. That results in resolution of 0.021/centimeter. We use a rather short micro window with only a few methane absorption lines. The central wave number is about 6004 1/centimeter, which corresponds to about 1.665 microns. The vertical information is in the shape of the absorption lines. The absorption features at different ambient conditions are presented on the right. The absorption lines are narrower at high altitudes with low pressure and low temperature, in comparison to ground pressure and temperatures, where the lines are broadened. Traditionally, the retrieval of methane concentration is constrained using prior scaling method. The prior knowledge is collected from other measurements to create an estimate of the prior profile. The estimated prior shape is then scaled to find the best correspondence between the measured spectrum and the spectrum modeled using the scaled prior profile. Rather than trying to find a multiplier to the prior profile to find the best match between the modeled and measured spectra, we let the profile shape vary. To constrain the retrieval, we use dimension reduction, and instead of retrieving 100 levels independently, we only have 4 parameters to fit. The 4 singular vectors used are calculated from the semi-empirical prior covariance defined using ACE FTS methane profiles. We use 3 different prior profiles, summer, winter, and as a special case the polar vortex, as Sodankylä often lies below the polar vortex sometime during spring. The retrieved profile will then be the prior plus a linear combination of the singular vectors. Here we have 10 years of methane profiles retrieved. With a quick look, the stratospheric spring minima are easily detectable, denoting the time when Sodankylä is below the polar vortex. And the methane polar air descends from higher altitudes. A careful look also reveals the increasing amount of methane in the troposphere. Let's take a look at a single retrieved layer at about 6 kilometers more carefully. We have used a dynamic linear model code by Marko Laine to find a smoothly varying background change rate for each layer independently. Upper panel shows the data points, fitted seasonal cycle and the slowly varying background. Lower panel shows the derivative of the slowly varying background. For this layer we see that there has been a steady growth of methane concentration, but the growth has been a bit slower towards the very end of the time series. Here each layer has been fitted independently, and the results are depicted as a color plot. Results show a rather steady increase of methane in the troposphere, with slower increase until 2011 and then from 2017 onwards. In the stratosphere, very small changes happen until 2017, when there is a steep rise in the methane concentration. Though in the stratosphere the trends are not statistically significant because of the uncertainties that are larger than in the troposphere. To summarize, we have applied a profile retrieval method to a 10-year dataset of ground-based FTS measurements. The method is applicable to any ground-based high-resolution near-infrared spectra. The retrieved profiles agree well with other profile measurement methods, and comparison can be found from the publication. The trend analysis for Sodankylä data shows smaller growth rate towards the end of the time series in troposphere. Variable concentrations and high uncertainties hide the trends in the stratosphere, but the analysis suggests rise in the stratospheric methane concentration since 2017. I leave you with the references where you can find further info on the study and the methods. Thank you.